so let's learn about PVA. So our P represents position. And for position, our units are going to be feet, meters, millimeters, centimeters, feet cubed could be one if you're talking about volumes and anything like that. Okay? Our V represents velocity. And the units for our velocities are going to be feet per second, miles per hour, feet cubed per minute. Anything with per minute. So this is per something. Something per something. That's our velocity. Our acceleration, A stands for acceleration. The units for those would be feet per second squared, or meters per hour squared, or feet cubed for minute squared. Or to be fancy, we sometimes write meters per hour per hour. So we're adding another per. So if you notice the patterns of it, every time we go forward, so from position to velocity, we added per something. And from velocity to acceleration, we added another per something, so there's two different pers. So that's the relationship you can see. Unlike pre-cal, we're going to go ahead and define how we get from position to velocity. For you to get from position to velocity, you have to take a look at slope of the function. So if I look at the slope of position function, it gives me the velocity. Or we can also say rate of change. Or in calculus, we call this the derivative. Okay, because derivative is the slope of a tangent line. Likewise, if you go from velocity to acceleration, you have to look at the slope, rate of change, or the derivative at that point. Another vocab that I want to add to this one would be speed. I'm going to put speed under velocity, because we're not really sure what velocity and speed are, or if you know, you don't really know the difference between those two. If you do, that's great. The difference between these two would be that speed is how fast you're moving. So speed cannot be negative. However, velocity can be negative, because velocity is speed with direction. So velocity is speed with direction, which means speed is really absolute value of the velocity, which I'm going to represent as v sub t. While we're here, let's go ahead and talk about how we represent this in calculus. Position is usually expressed with x sub t. And that can be confusing because we're so used to x being x-axis and this number that we can plug in an independent value. However, that can be how it's expressed, or sometimes s sub t. Our velocity, as you can imagine, is expressed as v sub t, and our acceleration, a sub t. Having all of these down, let's kind of take a look at the relationship between velocity and speed a little better. But one takeaway that I want to have on here is that in order for you to get from position to velocity, you have to take a look at the slope of that function. Now, velocity versus speed. Speed cannot be negative. Okay, that's what we know for sure. So for example, if I tell you that my velocity, my v sub t, is negative 15 miles per hour. That doesn't mean that I'm going negative 15 miles per hour. That just means I'm going either left or south. So in this case, let's say I'm moving left or right. So I'm moving left 15 miles per hour. Does that make sense? The velocity is speed, but the negative and positive sign of velocity tells you which way you're moving. So any negative velocity tells you that you're either moving left or down or south. Any positive velocity tells you that you're either moving towards the right, east, or north, up. I hope that makes sense. Now, here's another thing that we need to know about speed. Speed can increase and decrease, and here's the things that we need to look for when speed is increasing and decreasing. And there was an activity that actually attached with this in pre-AP, pre-cal, and as of right now, we just don't have time to go over that again, so just trust me on this. Speed is increasing. This is how we know that speed is increasing. If and only if my velocity and acceleration has the same sign, Here's what I mean by that. So let's say, for example, at time equals 3 seconds, my velocity, so maybe I can be more specific, my velocity at 3 was -5, and my acceleration at 3 was -11. Do you see how both of these has negative signs? So therefore, this means at time equal 3, speed was increasing. Okay. Likewise, similarly, speed is decreasing when velocity and acceleration have different signs. Okay. So for example, in this case, if I gave you my at time equals 3, my v sub 3 was once again -5. However, my a sub 3 was 2. Then we know that speed is decreasing at time equal 3. Now, it's not very often, but they do ask whether or not speed is increasing or decreasing at a certain point, and this is how you can tell whether or not it's increasing and decreasing. Now, here's another thing that I want to do when it comes to PVA. There's language that goes with 3 of these things, so I want to go ahead and go over those as well. When we're talking about position, this is asking us where. So where are you at this time? Then we should be looking at the position function. But if they ask you, how fast are you moving? Or where are you stopped? So I understand this is kind of a weird question, but if a particle, if I am stopped from driving, if I'm stopped at a stop sign, that means my velocity or my speed is 0. So that's how I know that I'm going to say, whenever they are asking for where is your particle not moving or is it stopped, I know that I can go and set my velocity equals 0 to see where that would be. Okay, or if this is asking you anything about moving, if they ask you which way are you moving left or right? That's a velocity question because velocity has directions. Other ones, yes, it's going to tell you whether or not you're left of the original place or right of the original place, but it's not going to tell you which way you're moving, okay? So those are the distinguishable things that they're going to ask you about those things. You know what goes with what. Another thing that I really want you to know is that, I think that's light there. I can't remember anything else. So yeah, make sure you know that if it's talking about moving or stopped or When is it moving left? When is it moving right? It's really looking at the velocity, not the position. So we need to be clear on that. I think that's about it for this video.